Bismillahirrahmanirrahim. Assalamu alaikum to all of you. This is Abdul Wafar Abbasi here. Today we will discuss the second chapter of Class HSC Part II, that is the hydrogen. Bismillahirrahmanirrahim. These are the contents of the chapter. Number 1 topic is the position of hydrogen in the periodic table, then molecular hydrogen and atomic hydrogen, industrial preparation of the hydrogen, binary compounds of the hydrogen or called as the hydrides. Last one is the isotopes of hydrogen. As we have already discussed the reduced syllabus, so in the reduced syllabus there are the three topics which are in the reduced syllabus. Number 1, position of hydrogen in the periodic table, then molecular or atomic hydrogen, and then last one is the binary compounds of hydrogen. These are the three topics included in the new reduced syllabus. So we will discuss these three topics. First topic is position of the hydrogen in the periodic table. What is the exact position of the hydrogen in the periodic table? Look at this. This is the periodic table. We mostly place the hydrogen at the top of the group first A, or we can say that is at this position, or sometimes we say that is on the at this side also. So in today's lecture we will discuss the what is the position of the hydrogen in the periodic table. So these are the outlines of the question. Position of the hydrogen in the periodic table. We will discuss number 1, resemblance of the hydrogen with alkali metal group 1A. Hydrogen has similarities with the alkali metals first A group, and at the same time there are also differences as well. Second point which we will discuss, that resemblance of hydrogen with the carbon family. Hydrogen has some properties, similarities with the fourth A group, that is carbon family, and meanwhile there are also some differences as well. Third point is that we will discuss the resemblance of hydrogen with the halogen family, that is 7th A group, and there are also some differences as well. So at the end we will conclude the topic. So now we will discuss this topic in detail. So basically, position of hydrogen in the periodic table. In this topic we will discuss these three main ideas, that hydrogen has similarities with alkali metals, hydrogen has the similarities with the carbon family, and hydrogen has the similarities with the halogen family. So where we should place the hydrogen, but meanwhile there are also some differences as well. So let's look at this topic in detail. Position of hydrogen in the periodic table. This is the introduction. You have to write, as I have mentioned earlier, that you have to give headings and subheadings so that you can get good grades in the board exam. Position of hydrogen. Position of an element in the periodic table depends upon its electronic configuration and physical and chemical properties, as we have discussed in the chapter number 1, that elements are classified into periodic table according to their electronic configuration and on the basis of their properties. Hydrogen resembles the elements of first A, fourth A, and 7th A in some respects. Properties of hydrogen do not completely match any one of the above mentioned groups, like first A and fourth A and 7th A. That is why the position of hydrogen is still undecided, because hydrogen does not hydrogen does not have the complete, you can say that properties matching the complete properties with the first A, second A, and fourth A. No, hydrogen does not match the properties completely with first A, fourth A, or 7th A. That is the reason its position is undecided. But now we will discuss the 3 points one by one. Number 1, resemblance of hydrogen with alkali metals or first A group. Now number 1 point is that like alkali metal, hydrogen has one electron in its valence shell. Hydrogen has only one electron in its valence shell. In the same way, alkali metals also has the one electron in the valence shell. Examples: hydrogen atomic number 1 and it is in the first shell, that is K, and lithium is alkali metal, its atomic number is 3. In the first K shell, 2 electrons we can fill maximum, and in the L shell the remaining one electron we will fill in it. So look at here, 1 electron in valence shell of hydrogen, 1 electron in the valence shell of the alkali metal. In the same way, sodium has 11 atomic number. In the first shell we will fill 2 electrons, in the second shell we will fill 8 electrons, and in the last M shell we will add the last remaining electron, so there will be 1 valence electron. So this is the number 1 property. It's very much clear that hydrogen has the 1 electron in its valence shell. In the same way, these alkali metals like lithium and sodium also has the 1 electron in the valence shell. Now the second similarity is that valence shell electronic configuration of hydrogen and alkali metal, it will be same. Now how? Look at here. Examples: hydrogen has 1 electron, it is 1s1, and sodium has 11 electron, 1s2, 2s2, 2p6 and 3s1. So what is the similarity here? That the valence the electronic configuration, when we will discuss that the electronic configuration ends at 1s1, and look at here, that is also ending at the ns1. Third property, both hydrogen and alkali metals are good reducing agent. They have the property, they are good reducing agent. They oxidize itself and reduce other. Fourth property is that like alkali metals, hydrogen can also form halides. They can also form halides. Halides means compounds with the 7th A group. Like look at here, hydrogen will react with halogens to produce halides like HCl, hydrogen iodide. This chlorine and iodine are the halogens. Then look at here, first A group, sodium will also react with chlorine, potassium will also react with bromine. So like alkali metals, hydrogen can also react with halogens to produce halides. This is the similarity. Fifth one, halides of alkali metals and hydrogen ionized in the similar way in aqueous solution. When they are ionized in water, in aqueous, they will have their same cations and same anions. They will be ionized in the similar way. Like HCl, hydrogen will be positive cation, chloride will be anion. And look at here, the sodium chloride will also be ionized in the same way like hydrogen. Sodium will be positive, look at here, hydrogen is also in positive and chloride is in negative anion. So the ionization of the alkali metals and halides, that is same. Sixth property, like alkali metals, hydrogen can also form compounds with non-metals. Hydrogen will react with non-metals to form compounds, and in the same way alkali metals also react with non-metals to form compounds. First A group, sodium will react with sulfur to produce sodium sulfide. Sodium will also react with chlorine to produce sodium chloride. Chlorine and sulfur are the non-metals. And look at here, hydrogen will also react with sulfur to produce hydrogen sulfide, and hydrogen will also react with non-metal like chlorine to produce hydrochloric acid. So sulfur and chlorine are both non-metals and above mentioned examples. Now the main point is that differences. What are the differences when we compare the hydrogen with the first A group elements, alkali metals? Hydrogen is a non-metal, whereas first A group, they all are metals. This is the difference number one. Second difference is that hydrogen can form both covalent and ionic compounds. Hydrogen can form covalent bonding and also ionic, have the ionic and covalent both bondings, and it can form the both ionic and covalent bonds, but alkali metals can form only one ionic compounds with reacting with non-metals. Third one is that hydrogen cannot lose its electron, valence electron, but alkali metals can lose its valence electron. This is the third difference. Now the fourth difference is that hydrogen is a gas at room temperature, but alkali metals are the state. Hydrogen is gas at room temperature, all the alkali metals are at solid state. Fifth property is that unlike sodium or potassium, hydrogen ion is unstable in water. Sodium and potassium, like alkali metals ions, they are very stable when they form the compounds, but hydrogen ion is unstable and it will react with another hydrogen or with any other to produce a molecule or compound. Now the second main comparison is that resemblance of the hydrogen with the carbon family, fourth A group. Number one similarity is that valence shell of hydrogen is half filled like the elements of the fourth A group. Now look at this example. Hydrogen has one atomic number and we can fill maximum 2 electrons in the first shell. So number of electrons we can fill, that hydrogen has only one, so we can fill 1, and 1 is remaining, so that will be 50% shell will be filled by the electrons. Now carbon is having the 6 atomic number, it is the member of the fourth A group family, and we can fill how many electrons in the second shell? 8. But how many electrons we have in the second shell when we compare the electronic configuration of the carbon? In the first shell 2, remaining 4. So 4 we can fill in the second shell, but how many we have to fill in the second shell? 8 electrons. So 50% of the filling of the electron is done in the carbon fourth A group elements and in the first A, that is the hydrogen. So this is the similarity, that both hydrogen and fourth A group have half filled elements in the in the valence shell. Now the second very important property is that ionization potential and electron affinity of hydrogen and carbon are comparable. We can compare these hydrogen and carbon, they are quite, you can say that similar. Like look at this one, electronegativity of the hydrogen and carbon family are almost similar. Like hydrogen has 2.1, carbon has 2.5, silicon has 2.4. So it is near to one another electronegativity. Now the next is the differences between the hydrogen and the fourth A carbon family. Carbon is a tetravalent, but hydrogen is a monovalent. Tetravalent means the valence electron in the carbon, they are 4. Look at here, like in this way, so it can form the 4 single covalent bond with other. So that is the reason it has tetravalent, means 4 electrons, but hydrogen has only 1 electron. It can form the single covalent bond in this way. So that is the reason carbon is tetravalent and hydrogen is monovalent. Hydrogen is a gas at room temperature, but the elements of fourth A group, they are in solid state. Boiling point and melting point of hydrogen is very less than that of the fourth A group, as we know that hydrogen is a gas and the 4th A group are solid, so definitely there will be a huge difference between their boiling and melting points. So these are the differences when we compare hydrogen with the 4th A group carbon family. Now we will discuss the last comparison, resemblance of the hydrogen with the halogen 7th A group. Number one similarity is that both hydrogen and halogen require one electron to complete their valence electron. Like hydrogen require only one electron to complete its duplet. In the same way, halogen's 7th A group will require the one electron to complete their octet. This is the one similarity, number one. Second, both hydrogen and halogens are non-metal except iodine, which has the partial metallic character, but rest of all other have the properties like non-metals. In the same way, hydrogen has the non-metallic character. Third one, both hydrogen and halogens act as a negative ion when combined with metals. When halogens 7th A group react with the metals like sodium and chloride, so sodium will be positive and chloride will be negative. In the same way, when hydrogen will react with the metals to produce the hydrides, so sodium will be positive in the same way and hydrogen will be in negative. So this is another similarity of hydrogen with the 7th A group, that it will form the negative ion. Fourth property is that their molecules are very important point, that diatomic. Hydrogen is also in diatomic molecular form. Like 7th A group, they all are in diatomic, like chloride, chlorine, fluorine, bromine. We can write in this way: bromine Br2. We cannot write only Br. They are diatomic. Fifth property is that, like halogens, hydrogen can also form both ionic and covalent bond. This is another property, that hydrogen can also form ionic and covalent bond also like halogens. Now the examples. Hydrogen will form ionic bond with sodium hydride, and sodium will be positive here, hydrogen will be negative here. This will be ionic bond. In the same way, look at here, hydrogen can form covalent bond with the carbon, like as I have already mentioned, carbon is tetravalent, have the 4 valence electron, so it will react with 4 hydrogen, so it will produce the single covalent bonding. So in this way, this methane, here the hydrogen react with carbon to produce covalent bonding, and in the sodium hydride it will behave as ionic bonding. Now what about halogens? In NaCl this will be ionic bonding, and HCl is a covalent bonding, like single sharing of single electron, so this will be covalent. So in the same way, hydrogen and the halogens have the ability to form covalent and ionic bonds both. Sixth property is that both hydrogen and halogen form compounds with metal and non-metals. They both can react with metals and they both can react with non-metals as well. Hydrogen will react with the sulfur, which is non-metal, to produce hydrogen sulfide. Here the sulfur will be non-metal. Look at here, halogen will react with the hydrogen and it will produce the hydrogen chloride, HCl. Here the hydrogen is acting as a non-metal, so both have the ability to react with metals as well as non-metals. Now the differences: hydrogen has 1 electron in the valence shell, while halogens have 7 electrons, 7 valence electrons. This is the key difference. Difference number 2: electronic configuration of hydrogen is 1s1, but valence electronic configuration of halogens is because they have the 7 electrons, so ns2 2 electrons and ns5 2 plus 5 7 electrons. This is also main difference related to electronic configuration. Last one is that unlike X means halogen ion, hydrogen ion is unstable in water and reacts in the following manner. Halogen ion, they are stable, but hydrogen ion, as we have already discussed, that it is unstable. It will react with in water to produce hydronium ion. So these were the differences when we compare the hydrogen with the 7th A group halogens. Now, the unique atomic structure of hydrogen. Hydrogen has the unique atomic structure when you compare hydrogen with all other elements in the periodic table. Hydrogen is the only element which has no neutron in its nucleus. Conclusion: due to above reasons which we have discussed in the above slides, we have discussed similarities and differences. So due to above reasons, it is very much clear that hydrogen cannot be placed in any one of the above mentioned groups, because at the same time hydrogen has similarities and at the same time hydrogen has differences also. So why we are placing the hydrogen and at the top of the first A group? Because hydrogen has the valence electron s electronic configuration, and first A group and second A group are the s block elements. So that is the reason we are placing it on at the top of the first A, but there is no fixed position of hydrogen in the periodic table. I hope you understood this topic. This is very important topic on the basis of the paper point of view, because when we go through the reduced syllabus, so this topic is included in the reduced syllabus. Thank you. Allah Hafiz.